Hello friends, welcome to my channel Study Corner. So today we will discuss about what is electricity. Electricity is a form of energy or a flow of electrons around a circuit. There are mainly two types, which static electricity and current electricity. So as we see in the figure, flow of electrons around a circuit. Flow of electrons around a circuit is called the electricity. So, what is charge? If we rub two objects, then charge is generated. If this is one object, this is other object. If we rub both, then charge is generated. Now, you may be walking across a soft carpet and reaching for the doorknob, which is metal, when suddenly zap, you realize that when you touch the doorknob, you feel some electric shock, which is minor in nature. So, to know about the static electricity, we need to know about the nature of a matter. Normally, the electrons and protons in an atom balanced out, which is why mostly the matter you come across is electrically neutral. That's why we are safe by touching out each and every object. Otherwise, we feel this spark or shock by touching each object. We all have done this experiment by pencil and paper pieces. To understand the electricity, we need to start with atom. Matter is made of atom. Even everything in the universe is made of atom. Here we see electron, proton and neutron. Nucleus. In the center of the atom there is a nucleus which consists of the neutron and proton. Here in the red, it is a neutron, in yellow it is electron, and in the blue, which is proton. So now we have to move on electron. Negatively charged electron orbiting around the nucleus. Negatively charged electron which is move around the nucleus. They move around the nucleus in a circular orbit. Shell or the electrons found in it are called the valence electron. How easy it is for electron to move around depends on the material. It is depend on material. Materials can be either a conductor or insulator. Now we see what is conductor and what is insulator. But first, the number of the neutron and proton and electrons in an atom can tell us which material it is. Conductor and insulator. Conductors and insulators. Conductor, which is allow the free electrons to move freely through the solid. Conductor is allowing the free electrons to move freely through the solid. Here this is conductor, which is wrapped around the insulator material. Now insulator limit the movements of the electrons, holding them tightly. Insulator is limiting the movements of the electron and limits the movements of the electrons and holding them tightly. The example of the conductor is copper, aluminum, gold, silver, iron, bronze, brass, steel and mercury. While the example of the insulator is glass, plastic, rubber, air, wood, fiberglass and diamond. Electrons. If we take a conductor which conduct the electricity, there are free electrons which is moving in the conductor. Suppose we take this conductor, okay, which conduct the electricity. There are free electrons here. These are the electrons which moving in the conductor. So if all the electrons move towards this direction, if all the electrons move towards this direction, then you interestingly know that the current is flowing in the opposite direction. Then the current is flowing in the opposite direction. So can electron move automatically in this direction? So electrons can move automatically in this direction? The answer is no. In metal there are normally electrons. In metal, suppose any metal, there are electrons. So can we see there is a electricity in it? So answer is no. Then the question is why? So there is a free electrons, but all are in the random motion. So we move them in the particular direction and the current is in the opposite direction. See, in physics, some particular words we used is too important. As we use here, if all the electrons move towards the direction as we see in this. So if all the electrons move toward this direction, otherwise it is moves randomly everywhere. So back to the topic. If a net charge q flows across any cross section of a conductor in time t, then the current I through the cross section is I is equals to q by t. Then I is equals to q by t. It is the rate of flow of electric charge. The electric current is expressed by a unit called ampere. The electric current is expressed by a unit called ampere. The SI unit of electric charge. Is coulomb. In ninth standard, we discuss the electrons has a negative charge. Now we discuss how much. The one electron here, it has a negative charge. One electron is equals to 1.6 into 10 raised to 1.6 into 10 raised to minus 19 coulomb charge on one electron. It is for one electron. Now the number of electrons in 1 coulomb is equals to 6 into 10 raised to 18 electrons. Now 1 ampere is constituted by the flow of 1 coulomb of a charge per second. That is 1 ampere is equals to 1 coulomb by 1 second. Not. It is for information. 1 milliampere is equals to 10 raised to minus 3 ampere and 1 microampere it is equals to 10 raised to minus 6 ampere. It is used for conversation in examples. Now, the electric current is expressed by the amount of a charge flowing through a particular area in unit time. As we see, I is equals to q by t, where q is the charge and t is a time period. Schematic diagram of a typical electric circuit comprising a cell, an electric bulb and ammeter and a plug key. Here, this is the bulb, ammeter, key and the battery. An instrument called ammeter measures the electric current in a circuit. It is always connected in a series in a circuit through which the current is to be measured. This is the picture of a ammeter and we see why it is connected in the series further. Now here some symbols are there. It is the symbol of cell. The first one is a symbol of a cell. Second one is a battery, which is made of a different type of a so many cells connected in the series. And the third one is key, and the fourth one is ammeter, which is measures the current. And fifth one is electric bulb. So, electron moves in a conductor randomly. For moving current, we gave a direction to all electrons. Let's see how it happens by using a circuit diagram. As we see in the circuit, if we take a conductor in which the electrons can move randomly, its direction is anywhere, it is moves randomly everywhere. So battery has a positive terminal and electrons have a negative charge, so they are attracts and the direction of electron is in this direction. So from the other side, here electron have a negative charge also, and the other side of battery have also the negative charge, therefore they repel together. From other side they are repel, so the direction of a current, therefore the direction of a current in this direction. As we see, the direction of a current is opposite side of electron's direction. So a continuous and closed path of an electric current is called an electric circuit. Continuous and closed, continuous and closed, continuous and closed path of a electric current is called an electric circuit. Now if circuit is broken, suppose from here the circuit is broken, from anywhere the current stops, then the current is can't flow and stop, and the bulb does not glow. Thank you.